Thermal methods or thermometric methods. In thermometric method, some property of the system is measured as a function of temperature. A general accepted definition of thermal analysis is a group of techniques in which physical property of a substance or its reaction products is measured as a function of temperature while the substance is subjected to a controlled temperature profile. We will confine to three of the methods which provide primarily chemical rather than physical information about the sample of matters. Classification of thermal methods of analysis. It has two main types: thermogravimetric analysis and derivative thermogravimetric analysis. While thermogravimetric analysis is further divided into differential thermal analysis and differential scanning calorimetry. The property measured and apparatus used for different thermometric methods, like in thermogravimetric analysis, the change in weight of the substance is measured and its apparatus is thermobalance, and in derivative thermogravimetric analysis the rate of change of weight is measured and apparatus is thermobalance, while in differential thermal analysis technique different temperature is measured, apparatus is DTA, while in differential scanning calorimetry method heat evolved or absorbed, that is enthalpy, is measured and apparatus is differential scanning calorimetry. Three methods: thermogravimetric, differential thermal analysis, differential scanning calorimetry. Next, thermogravimetric methods. In thermogravimetric analysis, the mass of sample in a controlled atmosphere is recorded continuously as a function of temperature or time. As the temperature of the sample is increased, usually linear with time. Thermogravimetry is the measurement of the mass of the sample as the temperature increases. This method is useful for determining the sample purity and water, carbonate, and organic content, and for studying decomposition reactions. Instrumentation of TGA. This is the technique whereby the weight of the sample can be followed over a period of a time while its temperature is being changed. First, sample holder. The shape, size and material of sample holder, that is crucible, have an important effect on the shape of the TG curve, thermogravimetric curve. The size and shape of the sample holder depends on the nature, weight of the sample and maximum temperature range to be used. Sample holders are made of quartz, platinum, ceramics, stainless steel and graphite. Second component, recording. It is most important component of thermobalance. A good balance must fulfill the following requirements. First, its accuracy, sensitivity, and capacity should be similar to analytical balance. It should have an adequate range of automatic weight adjustment. It should have a high degree mechanical and electronic stability. It should have rapid response to weight changes. It should be unaffected by vibrations. The balance should be simple to operate and easy. Third component, furnace and furnace temperature controller. The choice of the furnace heating element and the type of furnace depends upon the temperature range being studied. Next, temperature sensor, that is thermocouple. The most common method for measurement of temperature is done by use of thermocouple. For temperature up to 1100 degrees Celsius, chromel and alumel thermocouples are used. For temperature up to 1750 degrees Celsius, thermocouples are made of alloys of platinum or rhodium are used. For higher temperature tungstens, thermocouples are used. Next, recorder. Recording system is mainly of two types. First, time-based potentiometric strip chart recorder, and second, XY recorder. Differential thermal analysis. Differential thermal analysis is measurement of difference in temperature between the sample and a reference as heat is applied to the system. This method is sensitive to endothermic and exothermic processes including phase transition, dehydration, decomposition, redox, and solid state reactions. Phase transition means substance changes from solid state to liquid state or liquid to gas after heating, etc. And dehydration means substance dehydrates, that is loses water. And decomposition means after strong heating substance get decomposed. Redox reaction means in the substance reduction and oxidation simultaneous reaction occurs, that is electron transfers between oxidant and reductant. Differential scanning calorimetry. Differential scanning calorimetry independently measures the rate of heat flow to the sample and a standard that are at the same temperature. Data is taken by monitoring the differential heat flow as a function of temperature. Differential scanning calorimetry is useful to make the same measurement as differential thermal analysis and has the added capability to measure heat capacities. Instrumentation, sensitivity, analytical balance, furnace, purge gas system for providing an inert atmosphere, microcomputer or microprocessor for instrument control and data acquisition and display. Example of TGA using weight loss versus time.